Camera on, roll number 2, 27, 26, 15. So let us start. वैसे कम ही आया है, 16 only present. So last time हमने किया था open mapping theorem. थोड़ा सा लंबा था वो उसका proof. So basically it says that क्योंकि अब हम उसको use करेंगे और इसको use करके कुछ और prove करेंगे. So it's one of the fundamental theorems. Says that if you have a bounded linear operator between Banach spaces that is surjective, D belongs to Bxy, and D is onto then of course X and Y are complete. So this is a Banach space and Y is also a Banach space. So then D of G is an open set in Y whenever G is open in X. This also implies that if T is 1-to-1 also, then T inverse is also continuous bounded linear operator. So if in addition मुझे लिखना चाहिए, if in addition, तो ये हमने प्रूव कर दिया. Let's come to जो हमने इससे पहले किया था, बाद में करेंगे. अभी हम ये कर सकते हैं. We do what we call the projection theorem. So projection theorem जैसे हमने किया था normal linear space में हमने projection का idea बताया था. If Y is a subspace of a normal linear space, X, then a mapping P from X to Y is a projection if P is onto, P belongs to, B is a bounded linear map and it's continuous and linear. P is linear and continuous. And third property, P square is equal to P. P is idempotent. P is idempotent. So, इसी से related कि when, what should be the properties of Y so that you can find this projection, right? And if then the question is another thing, that suppose now there exists a projection from a subspace. Now in the case of linear maps on finite dimensional spaces, in fact, in the case of suppose अगर मैं लूँ Rn, if you take a subspace Y, एक तो ये कि there would exist a projection from Rn to Y, वो तो होगा ही, and you can also write Rn as direct sum of Y plus some other subspace, जो हम अभी करेंगे. Say Y plus Y prime. Now Y prime is some other subspace. इसको हम बोलते हैं ना कि we can write it as the direct sum. We can break it into smaller subspaces. In this way, तो दो questions होते हैं. एक तो ये कि प्रोजेक्शन कब एग्जिस्ट करेगा वॉइड सबस्पेस पे, और अगर प्रोजेक्शन एग्जिस्ट करेगा तो कैन वी डू दिस, कैन वी राइट पी एज अ डायरेक्ट सम ऑफ टू सबस्पेसेस। सो उससे रिलेटेड हम एक क्वेश्चन करेंगे, एक थ्योरम करेंगे। बट बाय द वे हमने एक चीज की थी विद द हेल्प ऑफ हान-बानाक थ्योरम कि अगर वॉई फाइनाइट डायमेंशनल स्पेस है, right, then we can always find this map with the help of Hahn-Banach theorem. If it is a finite dimensional subspace of X, right? और हमने फिर इसका नाम दिया था, then we said y is complemented in X. Y is complemented in X whenever this map, this type of map exists. Okay. तो इससे रिलेटेड हम दो थ्योरम्स करेंगे बोथ वेज कि हम कब इस तरह से लिख सकते हैं, और अगर इस तरह से लिख सकते हैं तो कैन वी डिफाइन अ प्रोजेक्शन, मतलब अगर ऐसे हम इसको लिख सकते हैं देन वी कैन आल्सो, मतलब यहाँ पर इसका कन्वर्स भी ट्रू है इन दिस केस ना, अगर मैं आर एन लूंगा। सो एनीवेज लेट्स राइट डाउन द थ्योरम, तो फिर मैं साथ साथ बताता जाऊंगा। वो ये है कि इफ P इज अ प्रोजेक्शन ऑन अ Banach space, a Banach space X, अब यहाँ पे Banach important है, it has to be complete, and M and N are closed subspaces of X. नहीं, वैसे मैं थोड़ा जस्ट अ मिनट इसको मैं लिखता हूँ, ये क्लोज्ड होंगी वो हमें प्रूव करना होगा। M and N are its range, are the range of the projection, are its range and null space and its kernel, null space का मतलब kernel, then M and N जो है are closed linear subspaces of X, and we can write it as a direct sum. Subspaces of X, and X can be written as the direct sum of M and N. ठीक है, तो हमें प्रूव करना है कि अगर कोई प्रोजेक्शन है, अगर इसकी रेंज स्पेस होगी, which obviously would be a subspace, because just a minute, ये मैं रब करूंगा यहाँ पे, थोड़ी सी जगह खुल जाएगी। Okay, proof. Let M be equal to range का मतलब all of its range, that means P of Z, right, P of Z such that Z belongs to X. और हमें पता है रेंज जो होती है, range is always a subspace of a linear operator, and it's itself a vector space. N जो है, N is the kernel, and it is all Z belonging to X such that P of Z is equal to 0. ठीक है, now you have to remember projection means projection is a map from X to X, right? तो of course kernel ये जो है P of X जो होगा, it would be contained inside X, and of course kernel of X, kernel of P would also be, मैं क्या लिख रहा हूँ, kernel of P and a null space of P that's equal to N, this is my M, this is also contained in X, because kernel is always the subspace of the domain and range is always the subspace of the codomain, क्योंकि यहाँ domain और codomain same है, so they are both subspaces of X because P is a map from X to X. Okay, लेकिन we can think of P is a map from as an onto map to its range. तो यहाँ पे मैं ले रहा हूँ Px which would be contained inside X, right? Okay, because in this case it would be an onto map. Now it's a projection, so it's an onto map to this subspace, to this space, and of course it has those properties. It is linear, idempotent, and continuous. तो वो सारी चीजें इसमें है क्योंकि मैं कह रहा हूँ प्रोजेक्शन है. Okay, now we have to show that now since P is linear, should I write it like this? Now अगर मैं लूँ what is M, rather N पहले लेते हैं. N is equal to, it is equal to P inverse of 0, and since singleton 0 is a closed subset of X and P is continuous, so therefore N is closed. N is closed, right? Because inverse image of a and P is continuous. Sorry. क्योंकि ये प्रोजेक्शन है तो इट इज ऑन टू लीनियर कंटिन्यूअस एंड आइडेंटिटी. क्योंकि इनवर्स इमेज ऑफ अ क्लोज्ड सेट इज ऑलवेज क्लोज्ड अंडर अ कंटिन्यूअस मैप, सो n तो क्लोज्ड है ही. अब हम m को ऐसे लिख सकते हैं. नाउ m किसके बराबर है? नाउ m इज इक्वल टू p of z such that z belongs to x. अब मैंने जानबूझ के z लिखा है क्योंकि मैं इसको ब्रेक करना चाहता हूँ into x and y. वो मैं भी बताऊंगा. Which can be written all x, all z belonging to x such that p of z is equal to z. ये important है. Why? Let's do it. Now p of z is equal to x. Also p of z जो है that is equal to p of z. Sorry, z है ना? नहीं, मेरे कहने का मतलब सपोज p of ऐसे नहीं मिलेगा. Suppose p of z is equal to x, then p of z would be equal to p of x, which is equal to x. है ना? चलो यहाँ लिख देता. How should I write it? So you have got p of z is equal to p of x, which is equal to x, which is equal to p of z. So should I write it like that? अरे क्या हो रहा है? तो मुझे मिलना चाहिए p of z should be z. So if let me think ऐसे लिखेंगे इसको. Suppose z belongs to x, then okay ऐसे करते. Let z belong to x. थोड़ा आराम से करते हैं. Such that p of z जो है ऐसे करें. I have to use the idempotency. Idempotency कैसे करें? Okay, तो ये इसके बराबर होता है, ये तो मुझे पता है. So it is always हाँ ठीक है. देखो p of z is defined for all z belonging to x. So let this be equal to u, right? So I have to show that u must be then equal to z. Now u is equal to p of z. Also p of z जो है that is equal to u, right? Because p of z is equal to p of z, यानी p of z भी u के बराबर है. Now consider, now whenever इस तरह से मतलब ये हुआ ना, whenever z belongs to m contained in x, then p of z must be equal to z, because m is equal to all elements of the form p of z. यानी z को p of z को मैं replace कर रहा हूँ z से, लेकिन मैं मान रहा हूँ z must belong to m, then p of z would be equal to z. यानी इसको मान लो z. थोड़ी देर we can, because this is just a subset of x. यानी x के ऐसे elements जिनके लिए p of z z होगा, वही होगा range of pz, because it is a projection. So then I can write this as z belongs to x such that p of z is equal to identity of z. and using the point-wise addition and linearity वगैरह वगैरह, it would mean that I minus P applied to Z is equal to 0. Now, I comma P belongs to a bounded linear operators. It implies that because it's a linear space, I minus P belongs to the collection of bounded linear operators from X to Y. And M is just the inverse image of this 0 under I minus P. And since this is a closed set in y, sorry, या मुझे xx लिखना चाहिए वैसे, है ना, xx which is equal to b of x, क्योंकि यहाँ पे डोमेन और कोडोमेन सेम. पहले भी मैंने ये तो नहीं किया, राइट, चलो, बिकॉज यहाँ डोमेन और कोडोमेन सेम है और b x को हम ऐसे लिख देते हैं, जब क्योंकि p और i दोनों है मैप फ्रॉम x to x, यहाँ डोमेन और कोडोमेन सेम. एनीवेज, there's a closed set in X, therefore, and I minus P is continuous, therefore M is closed also. Now, since M and N are subspaces already, वो तो होती है, they are the range and kernel of a linear operator. So therefore subspaces, hence we have proved that M and N are closed. अब दूसरा हमें दिखाना होगा, एक तो हमें दिखाना था ये क्लोज सबस्पेसेस हैं, दूसरा we can write X as a direct sum of M and N. Now let Z belong to X. Let Z belong to X, then we can write Z as this small z as Z is equal to P of Z minus plus I of Z minus P of Z. Because Z is I of Z, P of Z cancel होगा. अब P of Z जो है, इसको मैं लिख सकता हूँ plus I minus P of Z. ठीक है? Now obviously by definition P of Z जो है वो belong करेगा हमारे M में, रेंज में. It's range of P, तो ये वाला वेक्टर जो है ये यहाँ belong करेगा. अब देखने हम दिखाएंगे ये वाला वेक्टर N में करेगा ना lie. And क्योंकि I minus P of Z can be written as, should I write it as, अगर मैं इस पे P फिर से अप्लाई कर दूं, P of I minus P of Z should be equal to, it would be equal to P of I of Z minus P of Z, but P is linear, so this would be P of I of Z minus P of P of Z. But I of Z is Z, so it is P of Z, और चूंकि P projection है, तो P of Z is the same thing as P of Z, so it is 0 because it is idempotent. What does that mean? That means I minus P applied to Z belongs to N, that is the of P, है ना? क्योंकि इसको vanish कर रहा है. So therefore I have got for every Z belonging to X, we can write Z as some X plus Y, where X belongs to M and Y belongs to N. तो इसका मतलब हर एक वेक्टर को लिख सकते हैं as a sum of M and N. लेकिन लेकिन हमें दिखाना है, लेकिन अगर हमें दिखाना है आप x जो है x की स्कैन, ये हम तभी लिखते हैं इसको एज अ दिस थिंग जब when x can be written uniquely as a sum of these two vectors in only one way, और वो तभी होता है जब m और n जो है they have only identity in common, वो सब स्पेसेस हैं और they have got only zero which is मतलब which is intersection, which lies in the intersection. यानी now to prove, तो therefore मैं कह सकता हूं यहाँ पे m and n span x, वो तो हो गया. Now to prove that x can be written as a direct sum of m plus n, it is sufficient to show that m intersection n contains only the zero element, the additive identity. So suppose p of z belongs to m intersection n. It implies that, देखो पहले तो ये है कि p of z जो है n में बिलोंग करता है, तो इसका मतलब क्या हुआ, p of z is equal to 0, ये कर्नल में है ना, और रेंज में ही है. सपोज मैं ऐसे में लिखता हूँ, बेटर ये है, अब ना यहाँ पे नहीं, ऐसे ही ठीक है. देखो जब मैं कह रहा हूँ p of z m इंटरसेक्शन n में है, पहले तो ये p of, थोड़ा सा मुझे नाम बदलना पड़ेगा जस्ट टू मेक इट क्लियर. सो इसका मतलब लेट u बिलोंग टू m इंटरसेक्शन, ठीक है ना. इसका मतलब u इज इक्वल टू p of z फॉर सम z बिलोंगिंग टू x, एंड साथ में p of u इज इक्वल टू 0, है ना. why, देखो p of z अगर रेंज में है तो p of z, और चूंकि कर्नल में है तो इसको ये 0 पे भेजेगा. It would imply that p of z would be equal to 0 for some z belonging to x or p of z belonging to there. So once I am done, तो p of z अगर 0 है तो it would imply that p of z is equal to 0, because p of z is equal to p of z, है ना, because p composition p is the same as p because it's projection. It implies that लेकिन pz तो u के बराबर है, इसका मतलब u must be equal to 0, यानी अगर इसमें कोई एलिमेंट है तो वो 0 ही हो सकता है. So therefore m intersection n is equal to 0 and x must be, and we are done. तो ये खत्म हो गया. इसका एक कॉन्वर्स भी है, यानी क्या इसका उल्टा भी हो सकता है. इफ आई, मतलब अभी तो हमने किया, अगर प्रोजेक्शन है, if there is a projection on x is a Banach space, then we can write x as, we can break it into smaller subspaces. अब converse क्या होगा, if I can break it into two subspaces, does there exist a projection? So answer is yes, provided m and n are closed subspaces and x is a Banach space. तो वही हम इसका converse एक तरह से करेंगे. It's not exactly converse but some converse जैसा. Now let x be a Banach space. अब इसमें complete होना जरूरी है, मतलब Banach is important, and let m and n be closed subspaces of x such that x can be written as a direct sum of m plus n. If z, now if that's the case, if z equal to x plus y is the unique representation, क्योंकि अगर डायरेक्ट सम है तो हम इसको एक यूनिक रिप्रेजेंटेशन लिख सकते हैं of z belonging to x as sum of vectors in m and n respectively. अब हम दिखाएंगे then there exists a projection. Then there exists a projection. There exists a mapping, a projection P from, या सीधे लिखते हैं, then बेटर ये है कि हम मैप को पहले लिखें. Then PZ equal to X is a projection on X whose range and null spaces are M and N respectively. ये एक तरह से उसका कन्वर्स है, लेकिन चूंकि हमें ये जो लाइन है बीच में डालनी पड़ रही है कि वो प्रोजेक्शन ऐसे होगी, तो वहां पे हमने वो नहीं किया था, वरना हम लिखते थे इफ एंड ओनली इफ, वो लंबा चौड़ा हो जाता स्टेटमेंट. Now, so I've got P that is defined from, what do I have? P of Z is equal to, P is a map from, clearly a map from, what do I have? X to M, क्योंकि इसका रेंज X है और X बिलोंग करता है M में. Clearly P is onto, obviously इसकी रेंज ही ये है तो on to है, क्योंकि P of Z is equal to X. Exactly, for Z I have got an X here, on to है and linear है. linear कैसे? चलो linear करते हैं. P is linear. linear क्यों होगा सर? मैं अगर साइड पे ले, so suppose Z1 Z2 belongs to X, but X can be written as a direct sum of, so then Z1 can be written as some X1 plus Y1 and Z2 can be written as some X2 plus Y2, where Xi's belong to M and Yi's belong to N, and this is a unique representation. So Z1 plus Z2 होना चाहिए X1 plus Y1 and X2 plus Y2. Of course plus है बीच में, sorry. अब देखो, because addition is commutative inside a vector space, I can write it as X1 plus X2 plus Y1 plus Y2. अब X1 Y1 M, X1 X2 दोनों ही M में है, तो इसका मतलब this must belong to M and this must belong to N. So this is its unique representation as vectors, as the sum of the vectors in M and N. तो अगर मैं तुम्हें कहूँ what is P of Z1 plus Z2, it should be nothing but its M vector, यानी X vector. So it should be just X1 plus X2, which is the same as P of Z1 plus P of Z2. इसी तरह से वो स्केलर भी बाहर आएगा, so it is linear, उसमें ज्यादा कुछ नहीं करना. And P is idempotent. And P is idempotent. Idempotent का मतलब P square of Z is equal to P of X plus Y, isn't it? What is P of X plus Y? Yeah, P of Z, that is X. So it will be P of X. But that can be written as P of X plus 0. अब यहाँ कुछ भी हो Y है ना, तो it's like P of Z is defined as, because Z can be written as X plus Y. ये जो X part है हम इसको मैप करते हैं. So P of X plus 0 किसके बराबर होगा? It is just P of Z. No, it is just what? It would be X. That is the same thing as P of Z. So P is idempotent. P square of Z is PZ for all Z belonging to X. The only thing that remains to be shown is that P is continuous. Now to show that P is continuous, हम क्या करते हैं, यहाँ पे हमें थोड़ा सा मेहनत करनी पड़ेगी. अब हमें पता है x पे एक नॉर्म है ऑलरेडी। अब इस नॉर्म की मदद से तो ऑब्वियसली ये नॉर्म y पे भी होगा, है ना, बिकॉज y इज अ सबस्पेस ऑफ इट, तो y अंडर दिस थिंग वुड बी अ बानाक स्पेस। नहीं, मैं y क्या कह रहा हूँ, मैंने इसका नाम m दिया है ना। m जो है इसकी सबस्पेस, वो भी अंडर दिस नॉर्म नॉर्मल लीनियर स्पेस होगी, तो n भी जो इसकी सबस्पेस है, बिकॉज दे आर सबस्पेसेस ऑफ x अंडर दिस नॉर्म। अब इस नॉर्म की मदद से मैं एक दूसरा नॉर्म डिफाइन करूंगा ऑन x। सो वी डिफाइन another norm on x, जिसको हम ऐसे रिप्रेजेंट करेंगे, नॉर्म प्राइम, ओके, on x, and let x bar denote the normal linear space x, नहीं, vector space x equipped with the norm with this new norm, with the norm, इसको हमने ऐसे, ठीक है ना। So this is defined as norm of z prime is equal to norm of x plus y, because z can be written like this, हम इसको लिखेंगे norm of x plus norm of y। ये अपना ओरिजिनल नॉर्म, यानी x का मतलब है मेरा x विद रिस्पेक्ट टू जो ओरिजिनल नॉर्म था इसका, x प्राइम का मतलब है मेरा x जो हमारा दूसरा नॉर्म है, ठीक है। और दूसरा नॉर्म ऐसे डिफाइंड है, एक्चुअली हमें दिखाना चाहिए कि ये नॉर्म की सभी प्रॉपर्टीज सेटिस्फाई करता है। सो लेट मी लीव इट टू यू, होम असाइनमेंट। ये हमने बनाया है, डिफाइंस a norm on x। तो इजी है, तुम्हें इस नॉर्म की प्रॉपर्टीज यूज करनी है टू शो ऑल द प्रॉपर्टीज फॉर दिस नॉर्म। नाउ एंड x जो है is complete and it's a Banach space under this norm, and x bar is complete, and x under this norm, new norm, is complete, that is x bar जो है is x prime is also a Banach space। ये तुम प्रूव करोगे, ये इस होम में सच दैट, इसी में मैं लिखता हूँ होम असाइनमेंट में ही, x bar is complete। तुम्हें नहीं है कोशी सीक्वेंस, आई थिंक यू कैन डू इट, क्योंकि ज्यादा मुश्किल नहीं is a Banach space। होम असाइनमेंट तुम्हारा ये है, ओके। नाउ think about this norm of pz with the original norm। Now this is equal to norm of x because pz is defined to be x। This would be surely less than equal to norm of x plus norm of y, because I am adding something non-negative, but this is the definition of norm of z prime। So therefore by this p as a map, I can think of p as a map from x prime to x, मतलब they are the same vector spaces but with different norms। तो अगर मैं सोचूं इसको as a map from x prime to x, तो then p is continuous because p of z is less than equal to some k times norm inside the domain। यहाँ ये x है और इसके ऊपर प्राइम, then p is linear तो है ही, because p is linear, उसका norm के साथ तो कोई connection है नहीं, it's already by definition linear। So p is clearly a continuous linear map, of x prime into x। अब ये हमारा important था। Now suppose I denotes the identity map of x prime into x. Because as sets they are same, so I can define the identity map. Then I of z can be written as norm of z, which can be written as norm of x plus y, which is less than equal to norm of x plus norm of y, which is the same as norm of z prime. So that is, I got I of z is less than equal to norm of z prime for all z belonging to x prime. So therefore, I is a bounded linear transformation. Bounded linear transformation. Actually, I should write it is a bijection also, because identity is always a bijection from x prime to x, which is a bijection, and x prime and x are Banach spaces. Then by open mapping theorem, if you have a surjective linear map that's also 1-1 between Banach spaces, तो उसका inverse भी continuous होगा, यानी वो homeomorphism होगा. By open mapping theorem, I is a homeomorphism from x prime to x, that is x prime and x have the same topologies, which implies have the same topologies. So once same topologies, therefore P is a continuous map from x onto M. देखो हम इससे पहले दिखा चुके हैं P is a continuous map from x prime onto M, है ना. रेंज तो वही रहेंगी, रेंज तो फर्क नहीं पड़ेगा, लेकिन हमने दिखा दिया x prime और x की टोपोलॉजी सेम होनी चाहिए. Therefore it can be thought of as a continuous map from x to x onto M. तो मैं इसको थोड़ा 1 मिनट रह गया है, मैं इसको बंद करता हूँ, तुम फिर से ज्वाइन करो ताकि मैं इसको फिर से थोड़ा सा एक्सप्लेन करूँ यहाँ पे.